With an increasing interest in innovative approaches in math education, such as the use of programming and inquiry-based mathematics, and a recent call for more research to be done regarding this, we decided to look into what students value or take away from working on projects of this nature. This study is part of a larger study which works in the context of the MICA courses at Brock University. MICA stands for Math Integrated with Computers and Applications and is a sequence of 3 courses in which students engage in programming-based math inquiry projects. The larger, extended 5-year research study by the Pragmatics team at Brock, seen here, has addressed the gap mentioned by Lockwood and Morkin by examining the teaching and learning of using programming for engaging in pure or applied mathematical inquiry using the natural MICA environment. The study aims to better understand how university students learn to use programming as a meaningful tool for mathematics as mathematicians do, as well as how instructors and universities can support that learning. The team uses the instrumental approach as their main theoretical framework and has described students' learning with a process called instrumental genesis, in which students develop schemes to effectively use programming to conduct math investigations. This study has a similar context using the MICA environment to answer the preliminary research question, what do undergraduate math students perceive they learn from their engagement in programming-based mathematical inquiry projects? To do this, we looked at data from the larger study, namely post-course questionnaire data for 30 students across MICA 2, 3, and 3-star, which is specifically designed for future teachers. Particularly, we looked at the question asking what their biggest takeaway from the MICA courses was. The written responses were coded individually by myself and another member of the research team, consolidated, and then sorted into themes and consolidated again. From here, the themes were sorted into larger categories. After examining this data, 14 themes emerged, which you can see here, that were then reorganized into 4 categories. What programming offers, related to learning programming, interest in math concepts, and SEL, or socio-emotional learning skills. Out of the 14 themes, students most commonly indicated learning that or how programming is applicable or useful to mathematics as their biggest takeaway. This would include students' acknowledgement that programming has applications or importance in math. For example, one student responded saying that their biggest takeaway was how programming can be used to solve math problems. The next most common theme was programming is useful, which more broadly encompasses the usefulness of programming in the real world. This perceived usefulness or applicability that students took away from their engagement in programming-based math courses could be interpreted as students' appropriation of programming as a meaningful instrument, demonstrating their engagement in the process of instrumental genesis. For example, a MICA 2 student said, "Coding is a great way to gain a deeper understanding of math and is a great application tool to learn," showing how they are able to see how programming, an artifact, can become a meaningful tool for math investigations, an instrument. Looking at the bigger picture now, most responses related to programming in some way. That would be all those in blue or orange categories and themes, which may mean that participants found this to have a larger lasting impression. The large presence of both these categories is not necessarily unexpected, as they relate to the instrumental genesis, as explained before, but it does remind us that not only is the outcome important to students, but also the process. Now, what was more surprising was the presence of the SEL skills theme. This is because it was mentioned as the biggest takeaway, but also because it is not something explored through the team's current theoretical framework, and points to a need to explore this idea further. This is actually something that the team has started to do by also considering the theory of community of practice and its concept of identity development. So that brings me to what is next. An exciting outcome of this study is empirical evidence that appears to point to the concept of empowerment. The team may wish to further explore the idea of empowerment that programming may provide to undergraduate math students. This idea of empowerment was brought up by Papert in 1980 with his concept of using programming as an object to think with, and was specifically identified in Lockwood and Morkin's call for research that was mentioned earlier, where they wonder if for some students, opportunities to engage with numerical and algorithmic methods might expand their view of mathematics and empower them in their mathematical thinking and activity. There are also some limitations to this study, such as the small sample size and voluntary participation, as well as an uneven sample size between the courses. So this is just something we will have to consider moving forward.